Hi, everyone. I hope you're doing well. This is an extra video that is designed to introduce um, how to use model tables. You've been interacting with model summary tables for a while now, but frankly, they've been in a pretty crappy format, right? Um, Anytime we use the summary function, we get a model table for a regression table, but it's really hard to read. So how do we get cool model tables that look real slick and are easy to work with? We can use this package called TextReg. Um, and if you've never installed it before, you'll need to right now by running just this line of code. And then after that, you can just load it using library TextReg. So I just loaded it. I'm going to show how you can use TextReg to make nice model tables. And I'm going to show it through a regression of why some towns vote for the Liberal Democratic Party in Japan more than others over time. So to do that, we're going to download data from the Japan time series dataset from the years 1996 to 2017. These are the years that we have good data on the LDP and how much we vote for them. So we're loading that right here, and it's coming in right now. And let's see, there we go. We have 38,000 town years with 46 variables about them. That's a lot of data. By the way, you're working with big data. I know it doesn't always sink in. This is big data. Welcome to big data. Okay, so we can make, first off, a model of why some towns tend to vote for the Liberal Democratic Party more than others. Since this occurs over time, we should probably add a control variable year to control for the effect of time. Does it increase over time or decrease over time? We should also add a key predictor that we hypothesize affects that outcome. I hypothesized that wealth might have something to do with votes for the Liberal Democratic Party. So we've put that in our model, and we're going to test it. Okay, so we ran one model. It showed up here as M1. And let's say we actually wanted to know a little bit more about it. Let's say we wanted to know, hey, what if we control for age? What if we find the independent effect for age on voting, thereby weaning out any effect we used to attribute to income? So now the effect of income will be more specific. It will really be just about income and not about age. So let's try that. Okay, we've saved that in M2 now. Now, usually we could view the model table using the summary command like this, or for the second one, like this. But not so great, right? We could even make this a little bit better because Modern Dive, the Modern Dive package, I'm going to have to load Modern Dive real quick. The Modern Dive package, let's put that way up here, boom, has a nice function called getRegressionTable. And that looks a little cleaner. That's a little easier to interpret. They do have a dumb thing where they round a little too much so that effects just show up as 0. But, you know, they're doing their best, and it's very useful. Let's make a better table. Let's make a really good-looking table. We can do that using the screenreg command in the TextReg package. As you see right here, we're saying, hey, please grab the model tables from Model 1 and the model table from Model 2 and put them together. And we get this. Look at that. Isn't that nice? So what we see here is we have the estimate, the beta estimate, or the alpha coefficient, right? We have the standard error, which is discussed in lesson 13. We have them for each variable, and we can compare the effects across models. We can actually compare the effect size across models for the same variable too. This is pretty useful. So we see r squared down here. That's nice. And anything that's statistically significant gets stars, right? So if p is less than 0.05, you get 1 star. If p is less than 0.01, you get 2 stars. If p is less than 0.001, so it's really tiny, you get 3 stars. Pretty useful, right? We see, do these effects change over time? And as we discussed, what's really happening here is our variables are so tiny that the beta coefficient is really, really tiny right now, so it's kind of hard to see. But I'm sure that we could make that work a little bit better. For instance, all right. So we can also make this model table just look better in other ways too. For instance, ta-da! What did we do? Well, we gave new labels to each of these variables. We said, hey, please make year capitalized. Please make income per capita have nice spaces. And the same thing for median age. We did this all using the custom coef map function. So we're mapping the coefficients to certain places. What's also nifty is if we change the order below, it will change the order in the output. For example, income is now at the top. Kind of useful, right? And we did that by putting income at the top. Here's another one. If we remove a variable, it won't show up. So we got rid of year. So why would you do that? That's a good question. It's a little disingenuous. Sometimes you might do that if you have like 50 predictors in your model, and you've already told them these are all just control variables. They're not things we really care about. They were in the model, but we don't need to report the results. Like, what if you had the effect of every single US state in there? So you had 50 extra categories that each have their own beta coefficient. That would be a little tough. So you might exclude those. But you'd still describe your model by saying, and we controlled for state. We visualize just these effects right now. Okay? So we can also give each column its own column name. How do we do that? Right here, custom model names equals, and then we put in a little vector of column names for this one and this one. It goes first model, second model, whatever order you put them up in the list command. We also just added in the intercept right here at the bottom. Finally, actually, one more thing. We can do a cool thing. There are lots of options in here. We can say digits equals 3. And boom, now we have 3 digits. 3, what do they call it? 3 decimal places for each of our estimates, which is really nice. Gives us a little more detail. I suppose we could also have 5, but that's just a lot. So we can go back to 3 or the default of 2. Finally, we can use another version of TextReg called HTMLReg. It's like ScreenReg. ScreenReg makes it pop up on your screen, but HTMLReg saves it as an HTML file. For example, let's do that. And now you'll notice somewhere in here, in your files, there's now going to be one called table HTML. So let's find the T's. Here it is. And we can open in a web browser. Whoa! It looks so good! Oh my gosh! This is the really nice thing about TextReg. When you use the HTMLReg function, you can get really nice tables. And then you can just, you can take a screenshot of it. If you're using Google Chrome, fun fact, you can take screenshots pretty easily. Depends on your Chrome browser, but I can just do it by doing that and click take screenshot, and it'll get saved down to my downloads. You can also use a variety of extensions to get that out of there. For example, Clipular usually works pretty well. I see I have that down here. But they're really handy. So this is how you get really nice model tables. You'll also notice, as one final note, that you can imagine doing this for multiple models, right? If you want to verify, like, does income per capita really affect the vote share for the LDP? Then as you add more control variables, you'd want its effect to stay pretty similar. Even if it gets refined a little bit, you'd want it to stay pretty similar. That would really mean that, yeah, and income per capita not only has this bivariate relationship when you look at just income and vote share, but also when you control for other variables, that effect remains. So this is a good way to make models. Sometimes you start with the basic model that you really care about, and then you start adding additional controls. And that's a nice analytical strategy sometimes. It helps give you direction. So if you have any questions about this, feel free to shoot me an email. I hope that you enjoy using TextReg. It is completely optional, but very useful. Lastly, I hope you're doing well, and feel free to reach out if you have any questions about the course or want to do a one-on-one Skype to catch up.